of applause for Jace, please.
Thank you, thank you, thank you. Again, happy to be here. I see that all the cool kids are sitting in the back of the room again. Good to see that. Welcome, everyone. And yeah, what can I say? This is part two of my Varnish story. For those who weren't here for part one, previously on not 24, but previously on Plone Conf, I did this very elementary basic talk, Varnish caching in Plone, where I explained my journey in learning how Plone works, because I'm not a Plone expert, and how the caching is eventually set up. I've discovered parameters like these, settings like these in the panel, and being able to switch up the types of caching and exploring what they do and how to enable Varnish. So I talked about how to route front-end requests and back-end requests through Varnish and enabling all the caching types. You know the drill, right? The bullet points speak for themselves. So right now I'm going to take it to a little bit of a different level and talk about doing things at scale. Now, to all you Portuguese speakers out here, e aí, galera, tudo beleza? Yeah, great, great, great. I had to do that. That's the party trick. My Brazilian colleague, Lucas, wave to the audience. If you have questions and if you're not really comfortable doing it in English, talk to Lucas. He's Brazilian and he's one of our solution engineers. We also have Gunnar here. Gunnar, he's our territory lead for Iberia and for LATAM. Gunnar is not quite a Brazilian name. He's actually German, but his Spanish is really good. So that being said, my name is Thijs. Yeah, Thijs, well pronounced, gentlemen. Thank you for that. I'm the tech evangelist at Varnish Software, which means I do a lot of outreach. I do a lot of tech content videos, presentations like these. And I'm also an author. I wrote Getting Started with Varnish Cache, wrote that years ago. And as you can see on my facial expression, despite being very, very happy and honored to be an O'Reilly author, I'm not really jazzed about this presentation anymore. And I would not recommend, or this book, I wouldn't recommend buying this book. I would recommend getting this one, which is Varnish 6 by example. I wrote this really big, heavy book during COVID. I had a lot of time, spent a year and a half on it, and I'm happy to give away a free copy. I'm going to leave it there. Someone put it on that chair. I'll leave it there. I'll leave the room after this presentation, and we'll see if the book stays here or if someone actually takes it. I'm part of Varnish Software. By show of hands, who's heard of Varnish Software before? Very nice, great. We're a company that builds software-defined web acceleration and content delivery solutions. Very strong emphasis on software-defined. And most people know us from Varnish Cache, the open source project, that we are a spin-off of another company to support that. But we also offer commercial solutions that allow you to take things to the next level. This presentation is not a developer-focused presentation. That was more yesterday. If you're a Plone user, you want to set up Varnish, you want to learn the bits and pieces, that was yesterday. Today, we're going to talk about the operations. Varnish is a reverse proxy that's in the middle between the server, your Plone server, and your vault. Caches responses coming from the application, stores them in memory or disk, depending on how you configure it, and it sends it to users requesting it, ensuring that we take away a ton of pressure from those backend applications. And I've heard from various conversations that I've had here today and yesterday that Varnish is used quite a bit in these Plone contexts. I'll spend a minute trying to convince you that Varnish is fast, although I might be preaching to the converted. We'll see about that. So how do you define fast? I see three critical metrics that I tend to use, and those differ from one another. We can talk about network latency. A reduced network latency may make a site faster. Well, I can say from our perspective, we do sub-millisecond latency within the engine. So when I was preparing these slides and going over them again this morning, I wanted to ensure that I could back that statement up. So I did a little bit of a Docker container situation on my laptop, ran a request from cache, and delivered it in 400 microseconds. So the statement still stands. We do sub-millisecond latency. Of course, there's the thing called the network, and networks don't do sub-millisecond latency. So that's that. Throughput is also a big factor. I'm going to talk about throughput there, but also, of course, concurrency. Concurrency is a major one, ensuring that you can have low network latency, high throughput consistently, regardless of the number of users. So when we talk about doing this, and I'll provide a little bit of context. Intel, you probably heard of that company before, right? They do different types of tests. They want to test their latest and greatest hardware, new chips, based on certain workloads. And we were selected as a partner to check content delivery and web acceleration workloads. We provided our software, stock software, no hardware tuning, no tuning really in Varnish besides increasing the memory and increasing the threads. And they managed to get 1.5 terabits per second out of it on a single machine. That number might be way above what you expect or what you will ever need, and it might alienate you from reality. Like, who needs 1.5 terabits? It's just a number that we've got. What is more interesting is that that translates in 1.4 gigabits per second per watt. So from an efficiency perspective, we can process 1.4 gigabits per second using a single watt of energy. Yes, that was done on super big boxes, but it's commercial off-the-shelf hardware. We can give you the shopping list. You can buy the hardware. You can get there. When we talk about doing concurrency and high throughput, I was made aware by my colleague Lucas of a Brazilian website, which I had never heard before, but everyone knows it. All the Brazilians know it, right? Globo. Every Brazilian knows Globo, right? Great. So election season was up. Municipal elections. Most of you voted, I guess. Yeah. Well, we had to ensure that Globo could serve those results in real time. So maybe you're from Sao Paulo or Brasilia, wanted to see who your elected officials were or who was in the running. Well, we did that with a concurrency of 50 million requests per minute. So that was an interesting challenge, just for reference. So I hope by now, we're 5 minutes in, I convinced you of the performance capabilities. You don't have to worry that we'll run short of resources. It's also flexible, and flexibility is also key when we look at it from an operational perspective. And flexibility starts with the fact that we are solely software, meaning you have choice of infrastructure, choice of architecture. We're not shoehorning you into hardware or pushing you into a platform. You can literally run Varnish anywhere you want. If it runs Linux, we're happy. So if you're planning to run it on a server and install packages, we would recommend finding the packages on Package Cloud. So for open source, there's the URL. For enterprise, there's another URL. And you can see the logos of the distributions we support. So we have Debian-style packages and RPM-style packages with Ubuntu and Debian, and then, of course, CentOS, Red Hat, Alma, and Rocky. If you're a cloud person and you want to do it on the cloud in air quotes the traditional cloud way, which is kind of strange to say that cloud is now traditional, we have EC2 instance images like AMIs. We have the same for Azure, Google, and Oracle on those marketplaces. So if you don't want to set it up or configure it, ready to roll. There is a Docker image as well. You can pull it in, either the stable or the latest. Latest is the one that gets released twice a year and that is only supported for a little over a year. The stable one is our LTS. We had interesting discussions about LTS, didn't we, Fred? We've learned a lot from that, and yes, and we will. This is also part of my goal. Our goal here as representatives of Varnish Software is to take all that feedback in from the community, feed it back to internal discussions, and see what we can do with that. So yes, you can pull Docker images, either open source or enterprise, and run them. If you're on the more Kubernetes side of things, which some of you are, some of you aren't, based on my conversation with Eriko, then you can run our official Helm charts as well. I'm not going to go into depth on how to do it. There is a values.yaml file. You can set some parameters. It's pretty easy to spin up. So that's freedom of platform. Freedom of architecture goes into the realm of, and that's what I discussed yesterday. As I was discovering and learning about Plone, I was also learning about how to deploy it. And I've discovered Volto. I discovered the Plone backend. So you can choose to send all the page assets and then the pages themselves to Volto through Varnish, and all the external API calls to Plone. And then whatever Volto does with Plone internally, you can choose to either not cache it or route everything to Varnish and cache that as well. Or you can duplicate that and have multiple Varnishes and multiple Voltos or intermediary Varnishes. You can have multiple tiers of caching, if you will, where you have a storage tier where you can use sharding technology to actually store the hot content here at the top layer on the edge layer, and then shard it out horizontally on the storage layer if you have tons of data. And then underneath sits Plone and sits Volto. And you can distribute that. I mean, there is, if we approach it not from an international conference point of view, but as a Brazilian-focused event as well, there's places you can host that. And I checked on datacenters.com where the data centers are in Brazil, and they're focused around a certain couple of areas. I also noticed that the main cloud data centers are all around Sao Paulo and that area. There are opportunities to host it elsewhere. If you care about certain audiences more up north, more south, there are other data centers, maybe colo spaces, where you can actually put separate Varnish instances to, not just for throughput reasons or concurrency, yes, that helps, but solely for the sake of latency. I mean, I had to take a flight from Sao Paulo here, and that was like a blip on the map. Imagine the size of Brazil. So latency issues are very relevant in this country. Where I come from in Belgium, they aren't. I mean, you can drive 300 kilometers and we're done, right, Fred? And he lives in the Netherlands, which is slightly bigger. So you end up, and that's the key message here, with very hybrid architectures, where maybe you have a workflow that is very AWS centric, and you host that in, what is it? Where is AWS? Is it Rio or Sao Paulo? I don't know. Well, you do it there, but you're not forced to use the edge there. You can choose things in Fortaleza or Belo Horizonte or wherever you have other data center space. You can put instances. Those could be bare metal instances, could be virtualization, could be whatever. So that's a message. Don't be stuck into that one architecture. You have hybrid options. And because we are software defined, it doesn't really matter to us. Flexibility also comes under the form of the programming language that we offer in both Varnish Cache and Varnish Enterprise. It's called the Varnish Configuration Language, VCL. And it's a domain-specific language that allows you to tune the behavior of the cache. And if you are a Plone user and you've used Varnish, you've probably seen a little bit of VCL. The focus is not VCL today, but I'm just going to go super quickly over some VCL, where we have separate backends for Volto, separate backend for the Plone, an ACL where we put the IP addresses and the host names and the subnets of those systems that are allowed to invalidate the cache. And then we hook into VCL receive and normalize the URL to ensure that we use what you apparently call the virtual host monster to make sure that everything is aligned the correct way. I also normalized the host header because apparently in my Docker container, I had to put the Docker host name, which is Varnish, but the front end is actually on localhost on my computer. So I had to do a little bit of normalization. And there's purging logic, and there is routing the correct requests to the right backends. This is all me figuring things out on my own and using a little bit of information I found on GitHub. So it carries on and on and on. So that's the starting point, and that's where most people end their journey, either successfully or with certain frustrations. Where I want to carry things forward is look into specific things you can do as a more operations person and take it to the next level. And it's important you learn about configuration. And configuration is not just the VCL. That's just the behavior of the cache. I'm talking Varnish as a program. How do you configure that? Well, it all starts with systemd, right? You have a systemd unit file where you'll see an exec start. I'm trying to use big font sizes, and apparently I need it with the size of the screen. So if you're sitting in the back and you cannot see whatever I'm projecting, please let me know. So this is the start. And it's very defensive if you install it. It mounts itself to port 6081. And the reason it does that is if you install Varnish, sometimes it could be the case that another system running HTTP is also on the same machine. So we don't want to interfere. So by default, you're going to set that to port 80. And then you see the second one that's also there, which is a proxy endpoint used to terminate TLS, because Varnish Cache, the open source version, doesn't have TLS natively. So you need another system to terminate that. So it's mounted to localhost, assuming your TLS proxy will be on the same machine. But in the age of orchestration and cloud, that's unlikely. So you may want to set that open to other host names. Or you may, if you're using our commercial product, you have native TLS, and you could just annotate it with HTTP, HTTPS, and use certain commands to load certificates in there. That's that. That's port assignment. That's the TLS question. Then, of course, the storage is a big deal. I had to answer a customer question today about storage, like they're trying to figure out how to plan in terms of capacity, how to plan the amount of memory you need to assign, and how you can measure the usage. So by default, this is what you get. It's memory allocation using the open source Stevedore, as we call it. And it has a quarter of a gig, which isn't all that much. So you might want to boost that a bit, to be honest. What we also recommend is if you're doing this at super large scale, so I think the average Plone website will do with these kind of things. If you want to really take it to the next level, not just in terms of storage, but also management of memory, you could switch it up to MSE, which is short for Massive Storage Engine. And it's an engine we use at Varnish Software to actually bring the name's pretty obvious, right? To do very large storage. So what it really is a mix of memory and disk. And I know disk has a bad rep. I know that. Disk is always considered the slowest part of the architecture. But we're using pre-allocated large files with file system-like behavior on the inside. So that allows you to take away disk fragmentation and have limited file descriptors, all of that. And inside, there's this nice feature called the memory governor. A feature so nice, I had to make this ridiculous illustration of it. And what the memory governor does is it keeps a constant footprint of the Varnish process. Because that's something in open source that you have to be careful of. Maybe you assign 8 gigabytes of RAM and you think that's that. But there is, just like in all software, a runtime cost to running Varnish. So if you have this sudden onslaught of traffic, maybe you're doing a marketing, maybe you built this website and there's a commercial on TV in prime time and everyone goes to the website, the memory consumption could go way up if you have millions of users coming in. So there is dynamic resizing required based on runtime requirements. And MSC does that. By default, even if you don't specify this -p parameter, 80% of the memory will be assigned. And we will ensure that it doesn't go over 80% of whatever it is. If you would do a reboot and put new RAM in there, it will still be 80%. And we will resize the cache if the system suddenly needs more memory to handle threads. You can also set that to an absolute value, if you will. And if you need persistence and go way beyond what fits in memory, you can actually tie it into a configuration file. And in that configuration file, you can create metadata databases and also the actual stores on disk where you can store all that with a certain size. You run the command and you're good to go. You can also have multiple stores. Maybe you have multiple disks on a system. Maybe you want to tag these and then control where things are going to be stored. So here's a pretty stupid example, but it shows the purpose. So we hook into VCL backend response, which is the subroutine in Varnish that is used to when you receive something from the backend, from Plone, from Volto, and you decide to store it in the cache. Where are we going to store it? Well, if the TTL that was assigned is less than 2 minutes, then of course, why would you even bother storing it at the disk? It's going to be gone in 120 seconds. So in that case, set stores none. There's no storage on disk. It just lives in memory. However, if it's an image or a video based on the content type that we match into a regular expression, you can store it on large SATA disks, for example. Now, I said SATA, it's just a tag. I'm just trying to show you that you have different places to store. So you have control and flexibility from an operational perspective based on the type of patterns that you're receiving. The real tuning that I would recommend doing, especially at a certain scale, is thread pool tuning. Is relevant in every incarnation of Varnish, be it the stable version, be it the free, what's the name again? I'm drawing a blank here. The fresh version and also enterprise. Thread pool min, thread pool max is what you want to tune. By default, these values are a bit lower. So the minimum amount of threads you have, you need to figure out how many requests you have. But I can help you with that. I have a couple of commands from an operational perspective that will help you understand what is going on in your system and how you need to tune that accordingly. Just so you know, by default, there are 2 thread pools. So that means thread pool min is 500 per thread pool. That means when you start Varnish with these settings, you'll have 1,000 threads available. And it could grow all the way up to 40,000 threads, so 20,000 times 2. It is a subtle balance trying to figure out what the right thread settings are. Because if you assign too little threads, it will take resources and to spin new ones up. And if you have too many, well, each of them uses a little bit of memory. So multiply that by 40,000 and you can try to guess how much memory will already be gone on the system. Now, figuring out parameters can be done with this nice Varnish ADM binary that is installed on every Varnish server. And you do param show to show all the parameters. And this is what you get. There's a lot of them. I'm not going to go all over them. That's not the purpose. But you can do pretty interesting things like Varnish ADM param show changed to only see the parameters that are not the factory settings. See what you've done in terms of override, either at runtime or in your unit, systemd unit file using -p. And you can do that in a regular format. You can do that in an extended format, in JSON, you name it. And you can also change them at runtime. So maybe you are running a system at scale and you don't want to restart the system just yet, but you want to increase the threads. Well, you can do Varnish ADM param set, thread pool max, set it to a higher value. And eventually you will change the unit file maybe, and when the system restarts, it will pick that up again. So again, a lot of parameters to tune, not enough time to cover all of it. But what I would recommend, if you want to know what the parameters mean, go to the Varnish cache website. You'll find a docs page there. You go to reference, you go to varnish_d, and you'll find every single parameter and every single value. Or if you want to do it quick and dirty, just do Varnish ADM param show, maybe thread pool max. If you don't specify -l, it will give you the extended version and it will show you what the value is. So in this case, the minimum is 100, which is the factory setting. The thread pool max minimum value is 100, but we're using the stock setting, which is 5,000. So that's configuration. We've covered that element. if you see what we're doing here, the only real things you need to do to get started is tune the storage and tune the thread pools. There might be other parameters, but that's a battle you'll have to fight when you get there. Knowing when to get there relies heavily on observability. Observability in Varnish could be as simple as running Varnish stats. And I do a lot of support on Varnish, especially open source on Server Fault and on Stack Overflow and those subforms. I think 90% of all the answers I give either involve logging or statistics. Because people present a case, present a problem, and you want to have some insight on what's going on. So when you run Varnish stat, you'll see a continuously updated list of stats with the different metrics, and there could be, depending on your setup, more than 100 or 200 metrics that you can see into. You see current values, you see changes, and you see averages over time. It's pretty interesting. You can type D to show the zero values as well, but counters that have a value of 0 don't typically show up. You can do V to see more verbose metrics that usually don't show up. But you can also filter. So if you only want to see certain things, let's say you want to see session information, well, you can do -F and then use glob patterns to do main.ses asterisk, and you'll see all of them. You can also list them if you have a script or a system interpreting it -J to see them in JSON or XML, or just as with -1, you dump them once and it doesn't update. So here's an example of that. Varnish stat -F main ses asterisk -1, and it just dumps everything. What we can learn from it, if the font size is okay, right, is that there's 1,398 sessions being opened and they're being closed, and only 2 were queued, but there are no errors. Pretty decent. If you want to know the meaning of every single one of these counters, again, Varnish Cache has a good reference section there. Go to docs, go to reference, and use, what is it, VSC, Varnish Statistics and Counters, and you'll see every single counter. On our own developer portal, which lives at varnishsoftware.com, we also wrote a use case on a tutorial on how to measure performance issues, and also a typical question. I expected this to come out of cache and it didn't. Why? And we can give you all the debug things. So here's an example. You can take a picture of this if you want, but I'll publish the slides as well. So if you want to see this afterwards, I'll show you. These are a couple of those troubleshooting things you want to see. So is there workspace overflow at any point in time? Workspace overflow means a thread consumed more memory than that was assigned to it, which is a problem, right? Maybe you get a request, you try to do something, maybe a big header, process a big header, boom, it fails. Maybe you need to tune the parameter. Or maybe the threads were limited. You assigned an X number of max threads, maybe you needed more threads, and the others are queued, waiting for a free thread to do work. Or sessions that failed, sessions that dropped, requests that were dropped, backends that were waiting for some reason because of max connections on the Plone side. Or also an interesting one, NLRU nuked. So N as in the number of, LRU, least recently used, nuked as in meaning we had to remove objects from the cache using the least recently used algorithm, which means we find the least popular object in the cache and we move it, we get it out of the cache because there's a lack of storage. So all these metrics really help. And then you can see this updated list. What do we learn? There's 112 cache hits, 11 misses, 200 threads, 1.6 megabytes allocated in the storage, and a gigabyte left. That's troubleshooting purposes. You can also run a bunch of other stuff to get an all-encompassing overview of what's typically going on. So we care about the requests, maybe ESI requests if you use edge side includes, the number of cache hits, misses, passes, all that kind of jazz, backend responses, number of objects, yada, 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 purges you do, and then you can get a little bit extra. So we're seeing 4,245 connections with an equivalent of 4,384 requests, no ESI requests, 4,324 hits, only 14 misses, and 382 hit graces. Hit graces are interesting because that is a cache hit of an expired object. And rather than saying, hey, it's a cache miss, we need to fetch it, when we assign grace, we can give you the old version of the cache while we're doing an asynchronous revalidation of what's going on in the background. I talked about that yesterday in quite some detail, but here's the metric to see what's going on. Also, there were 36 uncacheable ones, 3 short-lived objects that weren't even stored in the main cache. So short, maybe it's less than 10 seconds, and so on and so forth. So all of that information is there. That gives you the helicopter view. what is going on the system? What do we need to improve, or how are we doing? Of course, then you want to dig deeper. And that's also something I do on Stack Overflow. I give people very detailed Varnish log commands, logs, right? Log commands that allow you to dig a bit deeper. And me and Fred had a conversation about that. You have to do that every so often, and it's always a nightmare. And you want to have, because you go back to our blog and find the exact command you need. I'm going to give a little bit of context about Varnish log. Yes, it could be a little bit of a hassle because there's so much logging information available. I'll take you through a journey here. This is going to be interesting. And I hope the font size isn't doing anyone any favors, I guess. Nah, I was hoping for this to be the screen, to be honest. So I think I used the size of 30 here, which is the absolute minimum I can use. I'll try it. Bear with me. So this is all the information. And I'm going to highlight what we want. The request started from an IP address called 192.168.65.1. So you see who connected to you on which client port, and it was an HTTP request. It was an HTTP 1.1 request for the homepage, a GET one. A bunch of headers were sent by the client. An interesting one was an if none match header with a weakened E tag. So that means it isn't the first time this user is sending a request. And it's also clear that Plone sent an E tag with the fingerprint of the content, and the browser captured that and sent that along. Very interesting. In the next step, we enter VCL receive, which is the state engine. So we received the request. In the next part of the story, we have more information, like we're seeing accept headers. My browser was apparently configured in English US, but for the sake of normalization, using a module we have in VCL, we've reduced that to EN to reduce cache variations when you would do a language-based variation. We deem it cacheable because we're going to hash. And what Varnish also does is it normalizes the accept encoding header, because we can store things in gzip by default. And if your browser doesn't support gzip, we will de-gzip it, un-gzip it, and send a plain text version. So that is what's happening here. We've looked it up in the cache, and it's kind of interesting. It is a cache hit. However, and that's really small font size, the remaining TTL of the cache is minus 745 seconds. So this object is a hit, but it has expired 745 seconds ago. But thanks to the 86,400 seconds of grace, which is 1 day of grace, which was configured in VCL, we can still serve the content. We can treat it as a hit. However, and here's a link tag that links to the backend request, we are going to do a background fetch. And that's what I expressed and what I explained, right? You can use soft purging or stale while revalidate to keep serving old content while you do an asynchronous fetch. Here's how you see that. And then, of course, when a response was returned from the backend, this is the response. It's a 200 OK that comes back, and you can do it what you want. However, before delivering it, we changed this to 304 not modified, because that's where Varnish is clever. It sees a response that's a regular 200. It knows the if none match header that came in. It knows the E tag, and it does the maths itself, and it says, hey, whatever we're trying to serve here, the user already has. It's a one-to-one match. So we changed it from a 200 to a 304 not modified and not sent any payloads. Kind of interesting. And all of that happened in 2 milliseconds. And then there's a little bit of accounting happening with the byte sizes. How much bytes were sent over the wire, what's the header size, yada, yada, yada. Now, I'm going to take you back to this one, the last line in yellow, link. A link tag is there to link another thread because the threads are decoupled. You have requests threads that handle incoming requests and responses we return. But if we have to talk to the backend, of course, there's another piece of the puzzle, and that is the BREC, the backend request at the top, and it has a different transaction ID, and it was linked. So that transaction ID 65643 should be, if we do it right, 65643. So it's linked. So there's a clear correlation between both of them. It is a background fetch. That meta information is there as well. And all the headers that were received by the user are copied in as a backend request and sent to the server, to Plone in that case. Then what do we have? We do a fetch. The fetch uses the Plone front end. Plone front end being Volto. So we've discovered a request that goes to Volto, and it came from a specific IP address, and we're sending it to port 3000 because that's what my Docker container is listening to. So this is one transaction, guys. This is just one log, a lot of information. The next thing we see is that we took, how many times? We took 20 milliseconds, 22 milliseconds to receive it from Plone. So Plone took 22 milliseconds to compose that result. Meanwhile, we added 117 microseconds in terms of processing internally. So you can capture all the timings. And in the end, we've returned the total waiting time for the backend response was about 30 milliseconds. And then, of course, we will return the response, we will return the headers, and we will store it in the cache. And you can see that it is deemed cacheable based on an RFC of 120 seconds, meaning someone sent a header of 120 seconds by default, but we've decided to override it and set it to 100 seconds for some reason. So that's a VCL, that's been done in VCL because VCL is used there. What else have we got? We injected a custom URL header for cache invalidation. We've unset the accept encoding and made it gzippable, and we stored it in malloc storage. That being that. Okay, so that was logging. That was one huge transaction log, both request context and backend response context for, I guess, was it the home page? I'm not even sure anymore. If you do that on a production system, you'll see that amount of information for every request and every backend request. So you're basically drinking from the fire hose, and that's not something you want to do. So you could filter. Those are those dreaded Varnish log commands that some people don't like. I tend to love them because they're so in-depth. So what do we care about is only displaying the URL. We don't care about anything else for purge methods. So that means whatever Plone is doing when you change something in Vault or the content changes and you have a Varnish attached to it, it will send purge requests. And these are the ones. So you can see that on my test page, Plone tried to invalidate test patch, did it for the API and a bunch of other resources. I'm not going to dive in too much more detail. I have a really extended developer portal tutorial on how to use Varnish log, which might be useful. But you can measure certain interesting things. So I care about slow clients. Well, then you can run the first command, which checks the timing of the response being returned being greater than 5. So that is a client that took more than 5 seconds to consume the response that we were sending. Might be interesting to figure that out. Or you want to do the same thing for slow backends. Maybe Plone is so slow that it takes more than 5 seconds to return a response. You could see that. Or you want to see things that are uncacheable or that were initially a hit but were expired and required a hit miss. Long story short, we have a VCL cheat sheet tutorial on our developer portal, which lives on varnishsoftware.com/developers. And I also wrote a really extensive one, which is actually, I ported my own blog post there because I canceled my blog and I wrote a really, really, really long blog post. Now, of course, a lot of people care about logs in a single line. And yes, we can do that. All that information, we can compact the useful stuff using Varnish NCSA. And NCSA is a uniformous standard for logs. Like this. This is what your web server emits. Is the standard format. So all of that stuff you can run with Varnish NCSA. And if you install Varnish, there's probably a Varnish NCSA systemd service running that already stores it on disk. If you need access logs, you're not going to find them on Volto or on Plone because we're caching. So this is the place to do it. What we do internally is also interesting. We have this free-to-use binary called Varnish gather, and you can run it on your system, and it will take a snapshot with a lot of information and will create a tar.gz file. And then we have this other binary called Varnish gather analysis, which does a quick analysis of it. Typically, you send the tar.gz file to us, and we'll analyze it, but we use this tool to get a quick snapshot. And this is the information we get out of it. You see the amount of hits, misses, threads, objects, nuking, session issues, and what we see here is a warning. 44 sessions were queued and 27 backend overflows did take place. So that's something to spot. That's something to look at. Now, of course, when we talk about logs, 5 minutes, no problem. When we talk about logs, we often want to centralize those. And that's something we don't have in our suite of tools. We don't have log centralization. But we also believe that we shouldn't reinvent the wheel. So why not use tools like Loki and Grafana and Prometheus to do that? In terms of centralizing metrics, we also have this tool or this custom vmod called vmodstat, which allows you in the uniformous format that Prometheus has to do /metrics will intercept that. And these are the general overview statistics that I showed you in that Varnish stat command. Maybe you want to list those in Prometheus format and scrape them. Well, it will look like this. font size even smaller. But the point is, this Prometheus will then be ingested by a Grafana, and then you can create these nice dashboards with native Prometheus support. Last bit of the puzzle is making it scalable. And we need to talk about load balancing and clustering real quick. So load balancing in Varnish is quite straightforward. You can have multiple backends, multiple Voltos, multiple Plones, and then you can create a director, which is a module that takes on multiple backends. And when you call the .backend function or method, it will expose a single backend based on a distribution algorithm. Could be round robin, could be something else. Of course, within the Plone VCL, we're already doing some routing there. It could be load balancing too, where you would call Plone.backend if you have multiple backends, and things would be sent to Plone or to Volto. And if you have multiple ones, they would rotate. So you can have round robin, which is the standard one, but you can also do random or fallback. Maybe you have multiple Plones. If one falls over, you'll take the next one. You can even use sharding if you want to at the Plone level, where you shard based on the URL, where you say these URLs will always go to that Plone and the other to the other one. That's also typically a solution that we use when we stack multiple caches on top of each other. The sharding methodology allows you to consistently hash an endpoint and ensure it ends up there. I did notice, or we did notice for years now, that there's limitations in there, is that you have to define all your backends up front. So there's no dynamic rebalancing, there's no dynamic backends. There's no DNS resolution at runtime either, which is kind of interesting. So when you specify a host name in a backend, Varnish will resolve the DNS record at compile time and will always know that IP address. If a DNS change happens at runtime, Varnish is unaware of it. And then a host name can only resolve into one IP address. So if you do DNS-based round robin, it won't work. What we found as a solution for that, and that's what we do with Varnish software, is we use two modules that we have called Active DNS and Udo to tackle that. So you can define templates for your health checks and for talking to Plone and enabling SSL if you use that. And then we're using this, where we create a DNS group, an active DNS group that resolves an IP, already knows the port. And we can assign a backend template and a health checking template. And in the end, we will parse everything into that. Same thing for Volto. We already inject the port number that we want to resolve to. And the active DNS, every time it sees a change at the DNS level, it will repopulate that backend. And then we can use Udo, which is short for Unified Director Object, to actually take that information in and sign up. It's like a pub sub thing. Sign up and subscribe to the information coming out of Active DNS, and then using it to do dynamic backends, but also maybe based on the random keyword you see there, randomly distribute traffic over those. So if you have one host name with 3 IP addresses coming out, it will use that. And the same thing for Volto. And then you only have to assign them using Plone.backend, and then that's that. Which also gives you the opportunity to do things like this. So I'm using Dig here on the Linux system to show you what goes on. Maybe volto.example.com is a C name that points to Volto 1, Volto 2. But maybe you want to do the same thing with SRV records, which is kind of interesting because that takes DNS-based load balancing to a service discovery level where you no longer really have to care about the port. And a lot of systems support SRV records. So what comes out is not just the 2 host names, but also the port numbers that Varnish should route to and potential priorities that we should use to choose. So maybe we should prefer, in this case, we prefer Plone 1 and Plone 2, and Plone 3 is a backup. SRV does that. That's service discovery. And you just simply change it at that level, use the host name, and we will populate everything. And if you're in an orchestration world, maybe Kubernetes, those Kubernetes services that you have a regular service discovery name, like Plone, Volto. If your service is called Plone in the default namespace, those will be the host names. Same for Volto. But you can do the same thing here by specifying the named ports with an SRV, and that could be used. I think I have about 1 minute left, more or less. That is clustering. We support that as well. If you use Active DNS, if you're an Active DNS user, you can import clusters.vcl, and we would synchronize those caches using tricks, using one as the backend for the other, and ensuring that they're kept up to date. And the final piece of the puzzle, I guess, is just showing that we have a control plane for Varnish as well. So if you have a lot of Varnish servers hosted in different regions or in the same data center, sometimes tough to manage them, we actually created an entire control plane with a graphical user interface to manage them. 1 minute. And that allows you to not only manage them, create routing to it, but also do centralized cache invalidation, which is kind of interesting. Because if you have multiple varnishes, you need to figure out like where does content live? How do I invalidate that? We have a central API, which is here visualized with a UI. You just say what you want to invalidate, and it will find where it is and invalidate it. And yes, if you want to, we also have a module to convert images, if that is a factor, if you need that. So we can easily, and that's really the last slide of content, check if it's an image or a JPEG or a PNG, and if the browser supports it, then we'll create a cache variation, compress the image into WebP. And if your browser supports WebP, we'll serve the WebP version. If your browser doesn't support it, we'll take the plain PNG and JPEG. And that was it. This is more an operational approach about tuning, about clustering, about using Varnish stat, Varnish log. I thank you for sticking around in this quite hot room. Thank you, Plone. It's been an absolute pleasure. I still owe you a book, though. Thank you. And if you want to have a chat with us about your Varnish setup or questions you have, me, myself, Lucas, and Gunnar will stick around for a little bit so we can have a discussion. Thank you.
Thank you, Thijs. Thank you, everyone. Anyone have any questions about the talk?
I don't want to put you on the spot. If you want to have a private discussion about these things, find us.
A question that gives you another minute for answering. You didn't show the dynamic loading of configurations, which is really cool.
Please elaborate on what that means, dynamic loading.
But that you can keep your Varnish running. You go to the Varnish admin. You said load a different configuration and make it active. That's a really operational nice thing.
I didn't show that. So in Varnish ADM, there's a subcommand called VCL load, and it takes a path. So while your Varnish is running, you don't want to restart systemd. You don't want to do systemctl restart Varnish. You don't want to do that. So what you can do is on a running Varnish, load the VCL file. It will compile the VCL, and if there are compilation errors, it will say right there, right then. And you give it a name, a unique name for that VCL. And then you can do VCL.use, name that, and it will automatically load it. You can also discard or show what VCL is running. But you don't need to use that because we have a wrapper around that called Varnish reload. So if you do Varnish reload on the system, it will just do that. And we also use it as a hook into systemd. So if you do systemctl Varnish reload, it'll actually call Varnish reload and will just reload the VCL. And that is that. Thank you.
So any more questions? So thank you, everyone. Thank you, Thijs.
Thank you.
A round of applause, please.